Hello, y'all. Good afternoon. We have a warm-up here. Ignore the fact that it says 11. But yeah, we have a nice little warm-up, and we're going to go over that in a few minutes, probably about 7 minutes, starting about 1:07. And then we'll go through our stuff today and hopefully get it done pretty quickly, and then be out the door and ready to take on the world. So yeah, feel free to ask me whatever questions you might have, and let me know. If you're just now getting here, feel free to throw a hi or howdy or something in the chat. Hey, Caleb. And yeah, let me know what you're that you're here, so I know you're here, so I know who I'm talking to. And yeah, we can get started on this warm up, and we're gonna go over it in a few minutes. Oh, we got a whole party here today. That's awesome. We got a few more minutes till we're hopping in. Probably started at the 1:07 with going over this problem. And yeah, till then we can just chill, do the warm up, hang out. Yeah, the angle is 102.9, Sebastian. Yeah, so the side AC is 14.9. The angle ACB is 102.9. And then the bottom side BC is 26.5. Alright, let's start going over this one because we can, and we'll get started with the lesson today. Alright, so first things first, we don't know any angle across from a side, okay? If we did know that, we'd want to use law of sines because law of sines is easier. Because we don't know that, we have to do law of cosines to find this side first, okay? So we know law of cosines. We can use the angle across from it for the find the side for law of cosines. We use the angle across from it. Law of cosines reminder is c squared equals a squared plus b squared minus 2ab cosine of c. As my hand starts to warm up a little bit, my writing will get a little bit better. I know it's awful right now, but it'll get better. All right. So c squared is what we're solving for, so I'll just go to an x squared there. All right, a squared can be my a is 26.5. So I'll put 26.5 squared there. Plus b squared is 14.9 squared. And then minus 2 times 26.5. It's a lot to plug in, but really it's just plug and chug. This should say 14.9. I'll put an extra dot there. And then cosine of 102.9. To be honest, from here, I just plugged it all into my calculator. If you want to break it up, we do 26.5 squared and 14.9 squared, and then this all multiply together and break it in more steps. That's fine too. But when I plugged it all into my calculator, I got that x squared equals, where is it? 1100, 1100.56. And then square root both sides, you get x is 33.17. So that's here. So from here, we have to find angle B and angle A. And we can do law of cosines if we wanted to, and just keep going through, and you know, we have three sides, so we can find any of the angles using law of cosines. But honestly, I think that's harder than law of sines. So what I'm going to do from here is I'm going to do law of sines. And so I have an angle across from a side, so I can do law of sines. So I'm going to say sine of 102.9 over 33.17 equals sine of B. You can solve for A first. Sine of B over, across from B, side B is 14.9. Okay, when you solve this out, you just cross multiply both sides by 14.9 and then take the inverse sign, and you get that angle B is 25.8, I hope. Let me make sure I didn't read my writing wrong. 25.8. Once we know that, we can use 25.8 and then 102.9 to find angle A. So angle B is 25.8. Angle A is 51.3. If you have any questions, go ahead and throw them in chat. I'm going to give you all a second to think about that, see if anything is weird, if any you have any questions, and if we're feeling okay, we're gonna move on. All right. I'm hoping that's enough. If you have a question, I'll come back. Absolutely. But we're going to move on. What I want to do next, I just want to go through and just think real quick. Are we going to use... can you not just subtract the other two angles from 180? Yes, that's how I got angle A here at the bottom. Is by subtracting 180 minus 25.8 minus 102.9. Caitlin. Yeah, that's how I got this 51.3. You could set up another law of sines if you really wanted to. It would work out, but I just did the 180. So, just like real quick, just fly through these. Not even like actually do the problems. Just, is this law of sines or is this law of cosines? Okay? So for the first one, we have three sides, but we don't have any angles. Sebastian, sorry. I round to around the nearest hundredth. Sometimes I round to the nearest tenth. The biggest thing is try not to round early. Okay, so try to store them in your calculator. Try to leave the entire number until the end. But if you do round, just know you might be a little bit off. But as long as you're not rounding significantly, it shouldn't be too far off and it should be okay. And so, like, I guess the answer is leave the entire number until the end, especially when you're using your calculator. It's pretty easy to do that because you can just scroll up. You can store values in your calculator. I'll figure out a way to show you all that on Monday. Like maybe I'll get a document cam and show you how to store numbers in your calculator. But if you do round, if you're rounding to like the ones place or, you know, the tens place, like the 50, then that could get really far off. But if you're rounding to like the tenths or the hundredth place, it should be all right. So, as I was saying for this number one here, we don't have any angles, okay? For law of sines to work, we have to know at least one ratio of a sine of an angle over the side length, okay? And so to start this one, we'd have to do law of cosines to start this problem here. For number two over here, we do have an angle across from the side. And whenever we have that angle across from the side, you know, if you want to do law of cosines, have at it. I actually think you can't even do law of cosines on this one, actually. But sometimes you'll have a choice. But anytime we have an angle across the side, I use law of sines because to me, it's just easier. It just makes my life, I just think it's easier. So I would use law of sines here. Keep going. Once again here, for number three, we don't have an angle across the side. We don't know this bottom side length. We don't know QP. All right, and so to find QP, we'd have to do law of cosines. Here we do have them across each other. So we're going to do law of sines. That's not an L at all. Keep going. This one. So, to do law of cosines, right, you have to have two side lengths because you have to have at least two of the A or B, which we don't actually have in this problem. But at first glance, it doesn't look like we have a side across from an angle. But knowing what we know about triangles, we can find this angle K. We can just do 180 minus 112 minus 31. And when we do that, we get, just let me plug it in real quick, 37. Okay, so then we know that K is 37. So, 37 degrees, and then we can do law of sines from there. And so hopefully that's just a little bit of a, oh yeah, that's how we that's how we determine it. Just in case you were still having trouble with the worksheet from Tuesday and Wednesday. It was one worksheet. All right, moving on. We have a problem with lost signs, okay? Sometimes when we set up our lost signs, if we were just given an angle and two sides, sometimes things don't work, okay? So let's say hypothetically, we knew this bottom side right here. We knew this angle here. We knew this side, and we knew this side. So we don't know the bottom side. We know the angle between the dashed line and the line going up. We know this side and this side, okay? In this triangle over here, obviously we can see that this left triangle, the blue triangle, goes all the way out to there, like that. This triangle, this right-hand triangle, this red triangle, we still have the angle. Pretend it's the same angle. Pretend I drew it correctly. We still have the side. And we still have the other side the same. Okay? Because we have these two possible triangles, sometimes the law of signs messes up. Okay? Sometimes it doesn't give us all the possible answers. Sometimes there's multiple answers. If you think back to your geometry days, this is like what you were doing whenever y'all would do like angle, side, angle, and side, angle, side for congruence. Where if you had like an angle, a side, and an angle, you could show that the triangles are congruent. If you had a side, angle, side, you could show the triangles are congruent. If you'll remember, there's one that always tripped you up on, always tricked you, and that was side, side, angle. Okay? Side, side, angle does not work. Here we have a side, and an angle, and that does not work. Okay? Your teacher might even be a little cheeky and wrote it the other way with angle, side, side. Don't type angle, side, side. So whenever we have a side, and an angle like this in this formation, there are two possible triangles. So we have to go through and check and make sure we don't use that we know which triangle we're talking about. Okay? So what we're going to do to solve these types of problems is we're going to set up lost signs just like normal. We're going to solve for the angle B just like normal. We're going to solve for angle C just like normal. And then we're going to go through and say, like, wait a second, what about the other case? What about the other possible triangle that we have? If we're solving first for the blue triangle, what about the red triangle? And yeah, so we're going to do this number 3 together to show what happens, how to do it. And yeah. If y'all want to copy down these real quick, these like steps, it's pretty simple steps. You might not have to copy them. I'm going to start looking at this chart. All right. So for both cases, angle A is going to be the same because it gives it to us in the problem. You see the A up here? It gives us the problem. All right. Angle B, angle C, we don't know yet. We know side C is going to be the same for both. And then we know side A is going to be the same for both. Alright, I'm going to copy this chart over to the other slide. And then we will go through on how to solve like normal. Alright, so angle A is the same. So is B. Side C is the same. Side A is the same. Alright, so I'm just going to sketch a triangle just to help me think about this. Okay? This isn't necessarily our triangle. But we say here, so here's angle A at 33. Here's side A at 31. And then we can put angle C wherever we want. I mean side C, let's put side C up here. Because that matches our drawing from earlier a little bit better. Okay? So, when we're solving this problem normally, we would use lost signs to find this angle, to find angle C. Then we use that angle to find angle B, and then we use angle B to find side B. Okay? So we're going to do that just like normal. So 31 law signs says 31 over sine of 33. Side A over sine of angle A equals 33 over sine of C. I'm going to cross multiply real quick to start simplifying things. So then we have 31 sine of C equals 33 sine of 33. Divide both sides by 31. And you get sine of C equals, I'm going to plug this in my calculator, 33 sine of 33 divided by 31, 0.58. It's like 0.5799977 or whatever. Alright, so inverse sine of the answer, and you get angle C equals 35.4. Okay? So C equals 35, angle C equals 35.4 in this first case. We move on, we keep going. We can find if we find angle B, we find angle B by doing 180 minus 33 minus 35.4. So 180 minus all the other angles. And we do that, you get the angle B is 111.57 or 111.6 to keep the rounding consistent after I told Sebastian not to round. But I'm storing everything in my calculator. So I'm doing 6, but I'm actually doing 111.565. Blah 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 blah. Alright, so we keep going, and we can finally find side B by doing the law of sines. Shoot. Let me set that up. Grab my pen. We're still going to do 31 over sine of 33 equals x is what we're solving for. We're solving for side B over sine of 111.6. So x equals 31 sine of 111.6 all over sine of 33. Cool. Just plug that in our calculator. And you get that side B is 52.92. Alright, so we went through and solved one possible case, okay? The next thing we got to look at is look at the other possible case, okay? So if you think back to your unit circle, okay? So there's our unit circle, right? And we said that sine of C, okay, so we're looking down here, is 0.58, okay? So that means we were looking at where the y value on our unit circle was 0.58, right? And we said, oh, of course, the angle is 35.4. Right? But there's another possible sine value. There's another possible triangle. Another possible angle. We could have also done the big red angle. Okay? And that is why there's two possible triangles when we do side-side angle. Is because there's this other possible sine value way out here where things make sense, okay? And so we have to find that angle. And what we know with using our unit circle is that if the purple is 35, that means this reference angle over here is also 35 or 35.4, right? So to find the red angle, we just do 180 minus the 35.4 to give our other possible angle, angle C, to be 144.6. I know I'm rounding, but it's okay. If you didn't round and you had the foresight to keep it and write everything down, more power to you. If not, it's fine. So for our second case, the angle here is 144.6. Alright? So that means this angle, what we're solving for, angle C. This angle C is 144.6. Then to find angle B, we do 180 minus that minus the 35. So 180 minus 144, exactly like we did before to find angle B, but now we have the second possible angle. If y'all have questions, like if any of this is just like, wait, hold up, go ahead and ask. All right. So I've managed to put my foot in my mouth a little bit here. This problem doesn't work because it doesn't work with the rounding I've been doing, because whenever you round this much, you start to get... Oh, I'm silly. I'm sorry. We're actually okay. When we subtract it, we're going to do 180. I know this is confusing for y'all, especially because it's not in person. But we're going to get it right. We're going to make sure it's right. So 180 minus the 144.6. And then we're also going to subtract out the angle A. So we're going to subtract out the 33, not the 35. So we're going to subtract out 33 from that. Yeah, unfortunately, Sean, we're out till the 24th. And when you do that, you get that angle, angle B is 2.4. Then you do the law of sines, just like normal, to find side B. And when you do that, I'm not going to write out the work, because I think hopefully you're okay with law of sines now. And then you get that side B is 2.38. All right. So this has been longer, more complicated than I thought it was going to be. I don't want to just sit here and talk to computer screen all day. So what I want to do is I want to try one problem together on this next sheet. Okay, I'm going to talk a little bit before that about like what to watch out for, how to know. And then we're going to come back to this on Monday. And we're going to continue this on Monday and then move on to what else I had planned. But like honestly, this is getting kind of long. And yeah. So, things to watch out for with this law of sines. Things to watch out for is the way we know that we had two triangles is because we checked and saw this red angle here. Alright? And if this red angle works with, and if it's possible to draw a triangle with the 33 and the red angle, which was like, sorry, let me erase this real quick. If it's possible to draw a triangle with the angle of 33 and the red angle, which was our 144, and it's possible to have another angle here. So in other words, if 144 plus 33 don't add up to more than 180, if 33 plus 144 is less than 180, the second possible angle is this 144, then we have a second possible triangle. Okay? And that's what you have to check anytime you're given side-side angle. Two sides in an angle. In law science problems. Okay? So what I want y'all to do is we're going to try this next problem on your own. And then once you've tried it and gotten as far as you can, and then we're going to go over it, we're going to call it a day. So here is the problem. I'm going to start filling in things that we know are true for both triangles. First thing you have to do is check, are there two possible triangles? Well, first thing you got to do is you got to solve the first triangle. Then you have to check for the second triangle. And if there is a second triangle, then you solve the second triangle. And yeah. And y'all can be honest with me in the chat. Is this something that we need to just go over this one together as well? And then y'all will be fine and maybe we'll get a little bit more practice? Or is this something that we need to practice? Like, just give y'all practice, we'll go over it, and we'll be fine to be able to pick up with it again on Monday. Like, are we completely lost right now and we have no chance of doing this on our own? Or are we feeling okay about it and we want to try it? Alright, so I will give y'all a few minutes to try this, and then we will go over it real quick, and I'll probably just give all the answers, and then if you got all the answers right, then great, you're good to go, and if you didn't get them all right, we'll go over how we got there. So, yeah, let's say meet back in, I'm going to start going over everything at 1:40. So, Caitlin, basically, the only difference between case 1 and case 2 is for case 1, our calculator is going to spit out the right angle for angle C. Okay? But for case 2, because we know our unit circle, we know there's another possible angle where sine of C equals 58. Okay? Well, sine of C equals 0.58. We know there's another possible. We also have the red angle. Our calculator is going to give us the purple angle just fine. For case 2, we have to know that there's a red angle, and we have to be able to calculate the red angle. Okay, so the way we do that is by using their fact that 35 is a reference angle, and we find this red angle. Once we do that, we have angle C, and then you just do lost signs just like normal. Yeah, pretty much, yeah, what Sean said as well. Alright, so the answers for these, if you don't have it yet, that's okay. Just keep working. I'm just going to fill in the boxes, and if you're good, I'm going to have a survey for you to fill out before you leave, and I'll flash that. I'll get that survey up on the screen as well. But yeah, if you're good with this, you're good, awesome. If not, then stick around for a second and we'll go over how to get it all. And we're going to build on this on Monday. Alright, this is the survey. The first one is just the bit.ly. Hopefully that works. If it doesn't work for you, you can plug in the full survey here down here. This is just so I know that you're here, you're working hard. If these answers are good for you, these make sense, awesome, you're good to go. If not, please ask me how I got something. Please ask me a question. Yeah, I want to go over this with you. I'm not trying to just like leave you on the dust with this. The assignment that was going to be due Sunday, don't worry about that because we haven't finished the other thing that we wanted to go over it, and we will learn that on Monday. So thank y'all so much for being awesome, and please ask me a question. I'm gonna stick around here for a while until I feel like everyone's done asking questions, and then we'll be good. I got that, Sean. I got that 129.09. I did that by doing my 180 minus my 50.9. So if you think about unit circle, that's the alternate angle. So you think about the unit circle, specifically the top half, and we have this first angle that's 50.9. Then the 129.09 is this angle coming around here. So I just did 180 minus my 50.9. On my second side B, the way I did that is I just did law of sines. So once you have angle B, you can do law of sines to do, let's see here. So it's sine of 42 over side A, which is 25, equals, 1 second, Sean. Sine of 42 over 25 equals sine of my angle is 8.91 over x, and when you solve for x, Madison, I think you should get 57.9. I can double check that though. It's supposed to be 5.79, Madison. It's supposed to be 5.7. Oh no, and I can't erase it. Yeah, that's my bad. Alright, Sean. So the reason we did the alternate angle for angle C is if you think about these measurements that were originally given. Okay, so obviously angle A has to be 42 because that is the one that's given to us. We know that's the case. Okay, from here we think about a 42-degree angle. Okay, let me turn that into a dotted line. I'm sorry. So we have this bottom side here that we don't know about. Then here's angle A, which is 42. Right? And then this goes up, and it goes back down. So here's side A, which is our 25. Okay, I said that this was angle B. Okay, so this is side B that we don't know as well. And then we know that this side C over here is 29. Okay? And so the reason we are doing this alternate angle is because we're trying to find angle C. Okay? So angle C is down here, right? And we do log signs just like normal. We get popped out. Angle C is 50.9. Awesome. Okay? But if I had drawn angle A, instead of drawing it out like this with an acute angle for angle C, if I had drawn it like this, where we're coming down like this, side C goes up, and side A comes back down like this, right? Then our angle C comes here and it's obtuse, and that's why we have to have our alternate angle. It's because angle C has 2 different ones. Obviously, angle B also has 2 different angles, but we don't know anything about side B yet, so we can't do alternate angles for side B. So we have to do the alternate angle for angle C. Then use angle C and angle A to find angle B. Hopefully that makes sense. And once again, Madison, thank you for catching me on that. Does that make sense, Sean? Cool. Kaylin, did you get that case 2 stuff? If you're still here, you might not still be here. If you want to try the worksheet, you can, but honestly, some of the worksheets also have problems that have no triangles, or ones that have 1 triangle, and so because today was a little more complicated than I remember it being, and because we haven't actually covered everything on the worksheet yet, I would just not worry about it, and we'll do that Monday and Tuesday. Do the worksheet Monday and Tuesday. So no, I wouldn't worry about it. And I'm going to update that as soon as I get off this. Alright, I'm going to hope that means we are good, and I'm going to go log out. Thank y'all for coming, and I will see y'all on Monday for our live stream, when hopefully everything really cements into place and we feel good. Adios.